Gastrointestinal tract. Formation of the gut tube begins with folding of the primordial embryo. For orientation, let us look at the embryo as it folds in the longitudinal or sagittal plane during the 4th week. Observe the amniotic cavity, umbilical vesicle, oropharyngeal membrane, and cloacal membrane. Folding of the embryo results in the formation of a foregut, hindgut, and midgut, which is in communication with the umbilical vesicle. By the end of the 4th week, this communication narrows and becomes the omphaloenteric duct. Observe the allantois and a newly formed liver bud. Folding of the embryonic disc in a horizontal or transverse plane causes the lateral edges to merge in the median plane. As a result, the trilaminar embryonic disc is converted into a cylindrical embryo. Moreover, part of the endoderm becomes incorporated in the embryo, forming the midgut. Observe that the midgut is now suspended by a dorsal mesentery from the body wall. The median section of a 4-week-old embryo shows derivatives of the foregut. Let us begin with the development of the stomach by now looking at a transverse section from above. The stomach is attached to the dorsal body wall by mesentery, the dorsal mesogastrium, and to the ventral wall by the ventral mesogastrium. Note the right and left vagus nerves. The liver develops in the ventral mesentery and is attached to the ventral abdominal wall by the falciform ligament. The pancreas and spleen are formed in the dorsal mesogastrium. During rotation of the stomach, the dorsal mesentery is transposed to the left, forming the omental bursa, or lesser peritoneal sac. The embryonic stomach is a fusiform dilatation of the caudal end of the foregut. The primordial stomach apparently rotates 90 degrees in a clockwise direction in a longitudinal axis. Its dorsal border becomes the greater curvature and migrates to the right. The ventral border or lesser curvature moves to the left. Following rotation, the left side of the stomach becomes the ventral surface, and the right side is now the dorsal surface. The vagus nerves are also relocated. The right vagus nerve innervates the posterior surface, and the left vagus nerve supplies the anterior surface. The cranial part of the stomach moves to the left and inferiorly, and the caudal part right and superiorly. Observe the sac-like omental bursa and its communication, the omental foramen, with the peritoneal cavity. The liver bud arises as a ventral outgrowth from the distal part of the foregut. It divides into a larger part, the hepatic diverticulum, which will form the liver, and a smaller caudal part, which will form the gallbladder. The embryonic liver enlarges and fills most of the upper abdominal cavity. The diaphragm forms partly from the septum transversum. The stalk of the hepatic diverticulum becomes the cystic duct. Observe how it joins the hepatic duct to form the bile duct, which connects the gallbladder to the developing duodenum. The pancreas develops from 2 pancreatic buds, located between layers of mesentery. The dorsal bud appears first, and at a higher level than the ventral bud. As the C-shaped duodenum rotates to the right, the ventral pancreatic bud is carried dorsally with the bile duct. The ventral pancreatic bud fuses with the dorsal pancreatic bud. The ventral pancreatic bud forms the uncinate process and part of the head of the pancreas. The rest of the head of the pancreas, body and tail, are derived from the dorsal pancreatic bud. The pancreatic duct is formed from the duct of the ventral bud and the distal part of the duct of the dorsal bud. The proximal part of the duct of the dorsal bud may persist as an accessory pancreatic duct. Let us look again from above at a cross-section of the embryo. Following rotation of the stomach and duodenum, the pancreas and duodenum are now mostly retroperitoneal. The midgut will give rise to the small intestine, including the duodenum distal to the opening of the bile duct, the cecum, appendix, ascending colon, and proximal 2/3 of the transverse colon. By the beginning of the 6th week, the C-shaped midgut elongates and projects into the proximal part of the umbilical cord. This process is called a physiological umbilical herniation. The omphaloenteric duct, yolk stalk, connects the midgut to the umbilical vesicle. It is located between the cranial and caudal limbs of the midgut. Note the superior mesenteric artery, which supplies the structures derived from the midgut. Also shown in the diagram is the spleen, which begins to develop during the 5th week from a mass of mesenchymal cells in the dorsal mesogastrium. In the umbilical cord, the midgut loop rotates 90 degrees counterclockwise around the axis of the superior mesenteric artery. During the 10th week, the intestinal coils are retracted into the abdominal cavity. The cranial limb of the midgut returns first and moves to the right. It continues with a further 180 degrees counterclockwise rotation. The caudal limb, which forms the large intestine, moves to the left. Observe the cecum and transverse colon of the large intestine. At first, the cecum is located in the right upper quadrant of the abdominal cavity. Observe the different regions of the intestine: small intestine, ascending colon, transverse colon, descending colon, sigmoid colon, and rectum. The appendix appears as a small diverticulum of the cecum. Let us now consider the fixation of the intestines. The first figure depicts the intestines and mesentery. Note the splenic and hepatic flexures, the mesentery of the sigmoid colon, and the greater omentum. A cross-sectional view shows us the peritoneum, ascending and descending colon, and fixation of the intestines to the body wall. Note how the pericolic gutters are formed. A sagittal section shows the stomach, duodenum, and pancreas with their peritoneal attachments. The greater omentum, fused double layers of peritoneum, is attached to the great curvature of the stomach and hangs like an apron over the intestines. Most of the duodenum and pancreas, and the ascending and descending colon, have an overlying peritoneal covering, which fuses to the posterior abdominal wall. The small intestine, appendix, transverse colon, and sigmoid colon are covered by peritoneum and suspended by mesentery from the posterior abdominal wall. The hindgut gives rise to the distal half to third of the transverse colon, the descending colon, the sigmoid colon, the rectum, and the superior part of the anal canal. The terminal end of the hindgut expands to form the endodermal-lined cloaca, which communicates with the allantois and the terminal part of the urinary and reproductive ducts. A mesenchymal wedge, the urorectal septum, divides the cloaca into a ventral urogenital sinus and a dorsal rectum. The urorectal septum comes into contact with the cloacal membrane at the perineal body, and this area is subdivided into an anterior urogenital triangle and a posterior anal triangle. The ectodermal-lined proctodeum contributes to the development of the lower part of the anal canal. By the 7th week, the anterior part of the cloacal membrane ruptures, and shortly after, the anal membrane does the same.